All right, so I guess I should introduce myself. I'm new to the Lua community. I learned Lua last fall doing this really fun experiment I'm about to tell you about. I am actually from the Node.JS community. I started on Node before it was even popular, about 3.5 years ago. So if you ever research Node.js, I'm sure you'll run into my name somewhere. It's really cool, but the biggest problem I had with Node is V8's kind of a fat VM. Lua and LuaJit are both way, way leaner. And so I'm going to tell you about my journey porting Node to Lua, because it sounds like a great idea, right? So this is the journey from Lake JavaScript to the Strait of Lua. All right. So the plan. I just want to swap out the engines. And when Node 06 came out, there was this backend called libuv that was the C library. It's kind of like libev. It does all the non-blocking I/O. And that was basically the bulk of Node. So Node was no longer this custom JavaScript thing. It was a C library with JavaScript. And so I thought, what if I just swap out V8 with LuaJit or something like that? That should be quick and easy. Let's do it and be done, and we'll have Node and Lua. So I started looking into this, and libuv provides the non-blocking I/O, and there were a few other libraries. There was this HTTP parser C library. It's a fast HTTP parser. There's OpenSSL if you want, like HTTPS or crypto or MD5 or any of that. That's handy. And zlib for some other stuff. So there's some more C libraries. And then, of course, there's V8, which is the JavaScript engine that Node uses. So here's the plan for a new project that I called Luvit. It's going to be libuv, HTTP parser, OpenSSL, zlib, and LuaJit. Same stack, just change the engine. That should be easy. So why did I want to do this? Well, turns out that all the Lua VMs are much, much lighter weight than all the JavaScript VMs. I was working on WebOS at the time, and we actually have Node on the phones. The problem is Node is kind of heavy because V8 is kind of heavy. It starts out with 10 megabytes of RAM, just a bare process. And then you load your JavaScript, and by then you're talking 4,000 milliseconds just to start up your code. And that's insane because the UI is waiting on that. And so I wanted something lighter. And also, Lua has these things called coroutines, which you guys, I'm sure, all know about. Which, when you're doing non-blocking I/O, you can do neat things with coroutines to make it look like it's blocking because you just suspend your coroutine. I wanted to experiment with that. JavaScript does not have that. And this fast FFI and LuaJit looked cool, and there was a bunch of... And I wanted to do other things than just web servers. I've been doing web servers since the 90s. I'm getting kind of tired of that. I want something funner, like robots or games. So I began the journey. First, I had to learn libuv. I'm not a C programmer. So if you want to learn libuv, there's the GitHub repo. The documentation is basically one header file. And there's an IRC channel. And WebOS kind of got shut down, if you remember that whole HP story. And so I went and joined Cloud9, where Ben and Bert, the two libuv guys, work. So I now work with the libuv team. So that helped me learn it as well. In straight libuvc, this is how you make a TCP server. You malloc your server, you tell it what port to bind to, you listen to connections. It's callback-based C code, which I now wish it wasn't, but it is. It's callback-based C code. And it's actually a pretty easy-to-use library. And it's cross-platform. You can write the same code. It'll work on Windows, Linux, Sun, BSD, whatever. libuv handles all that nasty cross-platform issues for you. So here's more of just a TCP echo server. You gotta do manual allocation and check for EOFs, and it's a lot of code. So then I had to learn Lua, which luckily is not that hard. So I bought Programming in Lua 2nd edition, which is a wonderful book. Just read the whole thing straight through, and now I'm a Lua expert, right? It's a good book. And then I joined the Lua L mailing list, and Lua on Freenode, and met a few of you on there. And then bookmarked that manual. It's just one big long HTML page, and it's everything. It's great. So learning Lua was not that hard. And when I showed this slide at NodeConf about 5 months ago, I think 10 people bought the book right then and there. It was great. They're like, what? There's this language? Lua is not well known outside the community for whatever reason. So I decided to prototype some Node APIs. Can Node-style APIs work in Lua? It's a different language. The semantics are different. So Lua tables are like JavaScript objects. Quick, who all here knows JavaScript? Most of you? A little? So this stuff's not new. JavaScript has these things called objects, and there's inheritance, there are prototypes. Of course, in Lua, you can just do that with the index meta method. And something really neat is Lua can have anything as keys. In JavaScript, all keys are strings. And one annoying thing is when you're dealing with JSON, a lot of JSON has nil for values, but you want your key preserved. Can't do that in Lua, so I had to work around that. And there's no this, which I think is a good thing. I much prefer the explicit self with the colon syntax sugar in Lua. Because when you're doing closures, your nested function can still use the self from the outside. But in JavaScript, every nested function has its own this, no matter how you use it. And so you have to say var self equals this or something like that. So all in all, the languages are very similar with some minor differences. So the first thing I did was I made an object system, of course. And so I just have my prototype object, and it's got this new method, and I extend it, and here's a rectangle class with an initialize, and I'm sure you've all seen similar libraries like this. I've seen a few floating on your mailing list. And the Node has this core thing called an event emitter, where you can emit events and things can listen on events, and so that's a really naive implementation. The one in LuaJit is actually a bit more complex than this now. But as you see, it's not a lot of code. And I'd never done Lua before in my life. So this is a good sign. So here is a prototype API. On the left is Node. On the right is LuaJit. And I'd say it's a mirror. Just swap out the curlies for end and put some colons instead of dots, and you got the same thing. The languages are extremely compatible with the way that Node uses JavaScript. So I can just port the API directly. And then this was an early experiment where I was using coroutines where this require fs thing. Well, this one I returned a wrapped version of the module where all the methods, instead of giving you callbacks, would just suspend your coroutine and then resume with the data. And so you could do like sleep 1000, and it would suspend your coroutine, and 1,000 milliseconds later it would resume. And I thought that was cool. I now have much prettier syntax than this, because this is something I came up with about a year ago. So now I have to write bindings for libuv for Lua. And since I was using LuaJit, there are two ways to do this. I can use the C API, or I can use the FFI bindings. And of course, they both have their pros and cons. In the API, you got to write C functions that are callable. And in the FFI, you got to write a whole bunch of Lua code and give it all the C definitions. So here's with the FFI. So this is part of the header file for libuv. And there's some interesting things here. You see how it returns there a uv error t, that's a struct, not a pointer to a struct. That's not a good idea in LuaJit. In fact, I don't think that works at all. And there were some other issues, because libuv is callback based, and LuaJit only recently got support for callbacks in FFI, and even then they're not very fast. Mike definitely says it's not a good idea. So, and there's some more. It's kind of nice code. It's definitely less than the C code you'd write with the C API, but it doesn't really work. So here's how you do it with Lua's API. I am not a C coder. I learned C while writing this. But so here's getting and setting the process title, or different things that libuv can do. So like you can change what title it shows in top, which is kind of neat. So instead of saying LuaJit or LuaJit, it'll be like whatever you want. And you just the strings, and you've seen this kind of code before. So the C binding is obviously one, because the callback based is not FFI friendly at all. And also, a few people wanted stock Lua. Rackspace was using my program in production. In fact, they're the only users of LuaJit I know of. They basically wanted Node to use less memory. And so at the time, they were using Lua because it uses less memory than LuaJit. And so I couldn't use FFI anyway. So yeah, here's some of the callback signatures. There's lots of them. There's maybe 5 times this in the library. A whole lot of C callbacks. So, okay, maybe this wasn't just a quick project. This is getting hard. Well, now I got to bind all of the libuv functions, and I think nowadays there's twice as many. Because I recently started writing another libuv binding for just vanilla Lua. I'm going to put this library in Lua Rocks so you guys can all use it without converting over to LuaJit. And there's a lot of functions in libuv. So we've got some fs functions, some uv functions. Then you've got this class hierarchy all done in C structs that inherit from each other using a union. And there's all these different things, and they all have their own methods. So it's fairly big bindings. And some of these are harder because you give it a C callback, but you want to give it a Lua callback. And so then you got to like take your Lua callback and your state and a reference and store it in some struct and a void star. And then later in your C callback, you got to unpack all that. And then you got to reference your Lua stuff, or the GC might do bad things. And that was a lot of learning and a lot of work. This was hard. And in JavaScript, and people always complain that callbacks are hard in Node. They wish Node was blocking. They wish they had some way you didn't have to use callbacks. And I'm like, no, callbacks in JavaScript are not hard. Callbacks in C are hard. Because you don't get closures. You don't get any of that. You just have a static, flat, global namespace of functions. And everything you pass in is what you get. There's some global variables you can use, but in an evented system, probably not, because there's so much parallel stuff going on. So here's the void star thing that all the APIs have. And memory management is hard. I'm a scripter. I've done scripting languages my whole programming career since a long, long time ago. And having to malloc and free things properly is hard. I learned that valgrind is your friend. That program is awesome. Now, luckily, libuv stays out of the way. You got to malloc your own stuff and free your own stuff, so that's good. And yeah, the harder part was keeping proper references on the Lua objects, because I want to reference them enough so the GC won't take them away when I need them, but I don't want to reference them too much or I'll start leaking objects. And getting that balance was tricky. So I've already written at this point 12,000 lines of C code. I still need to write bindings for HTTP RCC arrays, OpenSSL, zlib, and the libuv API is nothing like the Node API, so I need to write all this sugar in between that translates the one API to the Node API because I want a Node clone. And I already have 5,000 lines of sugar code, and it's not even there yet. And then building this, you know what? I'm a scripter. Why do I have to have Make here and Visual Studio here and this here to build on all these platforms? That's insane. I think I spent more time working on my build system than on the C code. It drives me crazy. And of course, the JSON issue was kind of annoying, but that wasn't too hard. Other than the nil, it was pretty easy. So this is where I was saved by the community. Rackspace and some other people came in, and they did support for me. We had some people in New Zealand, some people in Russia, and they just came on IRC and started writing code for me. And I've never done a Windows build of LuVit, but there's Windows binaries. Someone else does that. I didn't write OpenSSL bindings. I didn't even write the UDP bindings because I don't really understand UDP. It's hard to write some code for something you don't understand. TCP I know pretty well. UDP is weird to me. And then they helped me design the crazy object system that LuVit uses. So the community helped a lot. And initially it was 4 times faster than Node, used about 20 times less RAM. Yes. And it was starting to converge with Node. So I made a website and a mailing list and a IRC channel. And pretty much it's only used by one company, but it's there. Now, that is the end of these slides. Let me show you something else. So this is where I need you guys. So I made this Node clone in Lua. I was basically just using Lua as an engine. But I've since learned a lot about the Lua ecosystem where it's pretty much everyone does their own thing. And not everyone wants to buy into this one binary that's your runtime. Because you might want to put Lua on this device, or maybe you're using LuaJit here, or you have this custom eLua here, and what I've heard from a lot of you is what you want is standalone bindings to libuv that you can use in whatever. Is this correct? Or who wants, let's raise hands, who wants a standalone LuVit binary that has my own module system and no compatibility with Lua rocks? I thought it was a good idea. All right, so only us Node people want that. Who wants Lua rock compatible libraries? Okay. Who even wants a callback-based event system? Okay, a few of you, good. Every time I mail Mike about it on the LuaJit list, he's like, just don't use callbacks. I'm like, you know what? I didn't design libuv. So I've recently started this new project called LuV, LuV. It's just Lua and libuv, just bindings, and they're C. And then I have this MoonSlice project, which is basically a collection of libraries that more or less gives you the same functionality as LuVit. But instead of cloning the Node API, I'm coming up with new APIs that are more friendly to Lua, where I consider coroutines, where I consider the things that are different. And I learn from the mistakes of Node. One of the things I didn't note is I defined Node's HTTP middleware format, where you can just insert a layer that is like gzip or authentication, and it's terrible. The API for this is very unusable, and so I'm making a new API and experimenting with it in Lua first, because it's fun and it's flexible. Why not? So this is LuV. That's not right. Let me try xargs. 3 lines of code. Am I missing a digit? I don't think so. No, I've got to be missing a digit. There's no way it's only 1,000. Maybe it is. I don't know. It's not a lot of code so far, and I've already bound about half of libuv. Enough to do a TCP server, enough to do timers, enough to do TTYs, pipes, sockets. I can, let me just show you instead of telling you. So, all right. Is that clipping on the left? Just a little. All right. So I'm going to require these bindings I wrote. And these are the libuv functions I've bound so far. So there's set process title, there's timer stop, TCP open, get total memory. I mean, all sorts of random stuff. I can get the window size of the TTY. And this is so that if I want to write a pretty printer, I know how wide the window is and I can wrap things properly. So these are all just random things that libuv has that Node has needed. Current working directory, and uptime. Where's one of the weird ones? CPU info. That's a fun one. Let's do that. So here we go. I've got a Core 3 at, what's this, 1.4 gigahertz. It's dual core, but with hyper-threading, so it looks like 4 cores. And so I just have that information. I guess that would be useful to some web server somewhere. You want to know what kind of machine you ran on. And I can get the load average. Is that what it's called? No, maybe it's AVG. Or not. Anyway, there's a bunch of stuff. Now this, I had to make my own REPL because libuv is non-blocking, and the normal REPL kind of does IO read and just blocks waiting for input. And so this is actually a non-blocking REPL using libuv TTY streams. And it's pretty fun. So let's run. This is fun typing backwards. Test web, okay. So this is a basic web server running on port 8080. Now let's open a browser. Hello world. Oh, you can't see that, wrong window. Ha! Let me try it again. Where is it? This is why I prefer mirroring. I guess I can't see it because the slideshow is full screen. There we go. And yeah, hello world. That wasn't very interesting, was it? But that's a standalone HTTP server, and it's pretty fast. In hello world benchmarks on my desktop, I was getting about 40,000 requests per second using 1 CPU core. I mean, I don't know how that compares to the various web servers you have for Lua, but that's about twice the speed of Node. So that's pretty good. So let me get to a more exciting example. This is one I made for my talk today. I was going to make a chat program, and then I ran out of time, but it's a start. So let's look at the server. That's too big. Let's make this not clip. No, I think it was better there. Okay, that's not clipping bad. So I still have yet to get used to the Lua module system, because remember, I wrote my own for LuVit. But for now, this hack works. I have a folder called MoonSlice Love that has all my libraries, so I just put it in the path. And that works. So here I'm using the native Lua OS instead of the one from libuv. So I get the environments, and I require app, which is my module that's my app. And in MoonSlice, an HTTP app is just a function that takes request table, not object, and a respond function. And the request table Has things like your HTTP headers and the request method and all the nice HTTP stuff you want to know, as well as a stream of the body. So if they upload in a file, you get a stream for that. And then respond is a function that you give status code, headers, and body can be a string or a stream. So it's a very simple API. And anything following that interface is an app. And then I have middlewares like this AutoHeaders middleware. And the way they work is you give them the app and they return a new app. So I'm just nesting functions and closures. So if I want a middleware that does authentication, I just wrap it. If I want a middleware that serves static files, I just write one. So it's very composable. You don't need external libraries. It's just built into the API format. This is much nicer than what Node has. And I want to port this to Node as well. But like I said, I'm experimenting with Lua first. And then there's this socket handler function. And what that will do is that will take a web app, which is this function that takes request respond, and turns it into a function that accepts a TCP stream. And it will take that TCP stream and do the HTTP parsing. And then when respond is called, it will do the HTTP formatting. So it's translating from an app to an HTTP stream. Now, I'm not binding this to any server, any implementation. Here I'm using libuv, but you can use anything that provides the stream interface. It can be a mock test. It can be, I don't know, if you have any other non-blocking socket libraries for Lua, you can use any of them. Anything implementing this format will work with this web library. And it does all the HTTP parsing for you. And then here is a TCP server using libuv. So I created it this thing, give it the socket handler, give it the app. I have an instant web server. That's all it takes. And then here I'm just looping over the interface addresses. This is really nice for giving demos. It'll see what my laptop was connected to and show all the addresses. And then down here is my run loop. I don't have an implicit run loop like in LuaJit. You have to manually say run once. And run once will block until there's an event. And it will return 0 when there's no more events. And this tick queue is a purely Lua thing I wrote. So you can say defer this function until after I return, but before the event loop. And so it just recursively, you can defer stuff till later. It's called next tick in Node. I don't know if anything exists like that in Lua. But anyway, that's the server. Now here's the app. It's a very simple app. So this await is this coroutine library I wrote that takes a callback-based API and suspends it and resumes it and gives you the results. So it's really handy. So I've got a MoonSlice app, which is a callable table, because all that app needs to be is something callable. So it's a table I can call using the meta methods. And so if a get happens to greet, I respond with hello world. If they make a WebSocket connection to socket, I start this WebSocket program that just echoes everything with hello. And I serve the public folder as static files, auto-index at index.html. This is a very high-level program. This is easy to write, but this is just using all these other libraries. So let's run this. So there we go. You can go to this IP if you want. 10.88.68.148. Okay. Open link. Does anyone need the IP still? Okay. Yeah, it's in my logs. That works. All right. That looks like a couple of you got it. All right, I'm going to move on. So it serves some static assets. This is just an HTML page with a little slider that I implemented. Nothing fancy. And if we go here and look at the Chrome, so let me refresh it. Can this get bigger? Yes. That's a nice thing they did. My buddies at Google give Chrome presentations all the time, so I'm glad they did that. And I like looking at the headers when I'm implementing HTTP servers, because this is a very low level. I'm writing all the headers myself in either library or my app. So the browser's making these request headers, I'm making these response headers. My static library has proper E tags and last modifieds, and it gave a 304 not modified response because the browser had requested with if none match. So I wrote all that in Lua 2 nights ago, and it's not a lot of code. So adding these functionalities to MoonSlice is very easy, and this program scales and is about as efficient as an Nginx static server, but it's all Lua, so you don't need anything else. It's not quite as fast, but it's pretty good, and there's send file bindings to libuv if you want to use send file to make it even faster. Right now I'm piping all the data through user space. But it's extremely flexible in what you can do. So let's test the WebSockets, because that's fun. So, hope I have this installed still. Yes. Connect WebSocket, localhost, because I'm also listening on localhost. And what was the URL socket in my app? Yep. So now I have a WebSocket connection. Hello, hello, hello. No, no, hello. What? Okay, that's cool. And I Control D. And somewhere up here, you guys are... Oh, I left a log in there somewhere. But, yeah, that's a basic web server. I didn't finish the chat program, I'm afraid. So, that's about all I have to show for now. I got a lot more stuff. And I got some really great ideas yesterday. One of the things I want to do is I want to have Lua development front to back on web apps. The really nice thing about Node.js is you have the same language, because all browsers are JavaScript. And so having JavaScript in the server makes a lot of sense. You're not switching languages. And Lua and JavaScript are close enough, it really confuses me. And so I've been thinking for about the last year, how in the world am I going to get Lua in the browser? And I know there is Lua.js, I think is what it's called, that translates Lua to JavaScript and preserves most of the semantics. And then I found one yesterday, I think Ignacio showed me, that's a Lua VM that interprets Lua 5.1 bytecode. And that's pretty cool. But what I noticed is Lua 5.1 bytecode is kind of heavy. It's about, I don't know, 3 times the size of the source code in my testing. And it doesn't gzip near as well. So that's a lot of data going back and forth across the internet. However, I looked at the LuaJit bytecode, and since it has so many more opcodes, it's a lot more compact. And so I think what I'm going to do is I'm going to write a web server using LuV and do a child process spawn out to LuaJit compile on the fly, and it will compile my Lua code to bytecode and then serve it to the browser, and the browser will then run it in a VM that I write that interprets LuaJit bytecode. And so your dev environment will be, you hit save in your editor, go to your browser, hit refresh, and instantly it's compiled and reloaded. I think it will work. And I used to do this with Flash development using the Hax compiler, which is an open source Flash compiler that runs on the command line. Back then I was a PHP developer. I just had an htaccess rule that forwarded it here, and I cached them and checking timestamps, and it was extremely fast. So I think I can do the same thing here. It'll be really fun. But what I really came here for this conference is to get your input on what do you guys want? Do you guys want another Lua web development framework, or are you happy with what you have? Are callbacks too painful? Do you want coroutines? I mean, that's what I came for. I'm interested in what you guys want to know. So, are there any questions or comments or anything you guys want to see? He's bringing a mic up. Am I way over on time yet? No.
I was curious how the Node.js community, considering the performance that you've gotten with this, how they feel about it and about Lua.
I've not gotten a lot of feedback from them. So I gave a talk. These slides you saw were my NodeConf slides. And they thought it was cool and it was neat, and they'd never heard of Lua, and that was it. They just moved on. And I think it's because it's not JavaScript. The JavaScript community is massive. There's JSConf, the next conference is in Amelia Island, Florida, and tickets go on sale Monday, and I guarantee you they sell within milliseconds. Maybe just seconds, but like instantly. If you don't have a bot scraping the site, you're not getting a ticket to the site. And we're like $500 tickets. I mean, this community is rabid. And I mean, obviously, this room is not 1,000 people, and these tickets were free. So they're very different communities. But I kind of like this community. It's fun. The JavaScript people like JavaScript, and a lot of times they make fun of me for. They're like, "Why are you playing with Lua?" I'm like, you know what? They got better VMs, and the languages are very similar, but in a lot of ways, Lua is cleaner. There's a lot of warts in JavaScript. Brendan Eich developed the language as an intern at Netscape. Have you all heard the history? I mean, what was it, 2 weeks to make the initial VM? And I've been working with the SpiderMonkey code, and it's the same code evolved over the last 20 years, or almost 20 years. I think it's like 16, 18 years. And it's nasty, nasty code. And they're afraid to drop backwards compatibility on anything because it would break the web. Whereas I've noticed Lua, that's not the case. You'll break backwards compatibility to keep things clean. So I guess to answer your question, they don't care. it's not on the radar. Maybe we'll just blindside them. I don't know.
Okay, so that's very, very interesting thing for me. So don't worry about the JavaScript. Did you check the size of the static compile? How big this thing is altogether with all the libraries?
Let me check. Because I have a TP-Link router, which I think is similar to your hardware in characteristics, and I couldn't get LuVit on there. LuVit was too fat because OpenSSL and everything's statically linked. But let's see how big this thing is. So I can't read that. 592, but I bet that's not stripped. 230, so it's kind of heavy, and that has libuv statically linked inside of it.
But no OpenSSL, no other things. So
yeah, this is just libuv. I'm not putting in all the other stuff. That's separate. In fact, the HTTP parser is a separate library. I couldn't hear that. I have not looked at LuaSocket at all, or what's the coroutine based one, Copas? So I don't know.
Copas actually is like 200 kilobytes of heap inside the Lua VM, so quite heavy.
It's quite heavy. Okay. I mean, I can show you the memory usage of this process I'm running. Somewhere. If I shrink that, I can see it better. So LuaJit and my server, it's running at 1.5 megs, so it's kind of heavy. But I mean, Node at this would be like 15, 20 megs. So it's definitely lighter than that. But for a lot of embedded stuff, that's too much. I mean, which are you thinking about for your work devices, or?
Yes.
Now, what's the memory on those? Like 4 megs, or?
We have 8 megabytes, but the binary should be no more than 500.
So this might work for you. And there are flags in libuv to strip it down, because libuv is kind of fat, as you saw. It's basically an operating system abstraction. So, and this is all on GitHub. It's all open source. So if you want to give me make files or whatever, you're more than welcome to contribute.
So I came to know of Node, I guess, kind of late in Node's popularity, maybe like a year and a change ago. And I have a friend who's really into it for very good engineering reasons. Like, he's very level-headed about it and so forth. And I got to asking him when I first heard about it, I'm like, since he threw out an entire infrastructure in Python and redid it all in Node for his startup, and he's really happy with it, but he doesn't have any blinders on, right? And I said, what's the benefit of this to you, right? I mean, the non-blocking, et cetera, and the event-driven loop and so forth. And he's like, those are the things that I care about. He's like, the fact that it's JavaScript is just, it makes it easy to find programmers, and it makes it trivial because people don't have to, have the impedance mismatch on the server and on the client side,
right,
which makes sense. And he's like, and essentially I'm doubling down on the fact that V8 developers, the VM guys at Google, will continue to win over time, right? Because we made the comment in the conversation, like the two things that came up in the chat were, I said, well, why not Erlang and why not Lua? Mm-hmm. But Lua didn't have, obviously, connections to libuv or libuv, et cetera, so that wasn't really an option. But it was like, why wouldn't you just do this with, a smaller language that's more, tightly designed and has better semantics and a better VM? And he's like, well, nobody knows Lua, right?
It's not like it's hard to learn.
Well, no, it's not. And it's a point that we disagreed on, but it's valid for what he was saying, right?
Right.
And he's like, as good as he's like, you're right, is that Lua is what it should be, but people already know JS, and so it's already just going to be that much easier to get them over to it. And Ryan Dahl has already written the non-blocking, part that you care. So I don't care about Node.js. My use case for this in Lua would be, since you were asking about use cases, is the few places where I use Node currently are for writing my own essential web servers or web proxies by hand that are essentially stripped down functionality. So They implement some very specific small subset of HTTP, and usually I'm doing it because I'm trying to man in the middle two different endpoints for the intention of messing around with what they send to each other, right? And it's easier for me to do that in Node in like, a page of code for the, headers that I want to mess with or the specific request pattern than it is for me to spin up all of that in Erlang, which is otherwise what I would do it in, right?
Yeah.
So that's all I care about. I mean, I can totally understand the response you got from the Node people. What made you decide to jump ship, if jumping ship is accurate, from like Node.js to Lua? Is it just strictly that the language is better, or that you like the VM design better, or?
So the two biggest things were
you seem to be the person that my friend Matt was saying didn't exist. So.
Yeah, I am technically one of the Node Illuminati, whatever that means. I'm like the third person on the mailing list in the world. And I still do Node for my day job. I write a ton of Node code for Cloud9. The two big things were efficiency. Like I said, V8 is a beast on these small devices. You would never get V8 on his home automation stuff. I mean, it's insane. The binary is like, I don't know, 5, 10 megs and starts out at 10, 20 megs of RAM. It's massive. And then it's slower, and the language doesn't even have coroutines. So I really wanted to experiment with something else. And writing bindings to Lua was really easy. The stack part of the API kind of threw me a loop for a while. But other than that, writing C bindings for Lua is really, really easy. And it's easy to build, especially the stock Lua. You just like concat the files and say make, or GCC, and you're done.
So this is kind of apropos of nothing, but at the time there was a big discussion in the Node community about because they were writing all their web servers by hand, in Node, and kind of making their own, backend essentially.
Right.
Although I guess people proxy now with Nginx or whatever. There was a big issue with SSL and how to handle SSL negotiation, which took forever, right?
Yeah, Node still kind of sucks at that. It's better now.
Okay. So, I mean, is that you expect to have the same kind of problems with the way that you're implementing everything here?
I don't know. I didn't do the OpenSSL bindings for Luvit.
Okay.
And I don't plan on doing them for this new project because it's just too hard.
Okay.
Like Voxer, if you've heard of them.
Yeah, so Matt Randy is my former housemate.
Right, okay.
So, yeah, he's the guy.
I know Matt very well. So his story is they have this walkie-talkie app for mobile apps where you like press a button.
Yeah, please explain this, because I was trying to describe it last night at dinner and nobody understood what I was talking about.
Basically, it's a really, really high-performance HTTPS proxy. I think they do 1 billion HTTP requests a day or something like that. And they were C++, they were Python, it wouldn't work. They went to Node, and Node works great, except for the SSL. And yeah, they ended up putting a proxy in front of it. They couldn't use Node's SSL at all. And I think it's just implemented badly. Because OpenSSL is a hard-to-bind-to library. I haven't looked at the Luvit bindings. That was all done by Rackspace people. So I don't know. Any more questions?
For the SSL, did you look in the thing called AXTLS? Nope. It's like a very, very small SSL library that I'm also considering using inside.
No, but that sounds interesting.
And it has some, I think, I forgot the project name. There were some Lua bindings already.
Okay. Yeah, let me see. Cheating. Which Luvit? Yeah, so Luvit's 4 megs for the binary. So it's a bit heavier. We're done? All right. Well, thank you very much.